Hi guys, Miss Michelson here. Today I'm filming a video going over the topic 8 review all over our right triangles in trigonometry. I've got my assignment put up on Savvis, but remember you got to find it on your Canvas page first before it'll load. And it is 13 questions, so we're going to go ahead and get started. I do have my calculator pulled up and just in a place for my face. That's going to be annoying. Maybe here? Nope. Here's fine. So the first question is asking me to find the value of x. If necessary, write your answer in simplest radical form. Oh no. In simplest radical form over here. So that should be our little hint of how we're going to need to solve this problem. If I know two side lengths of a triangle and I'm trying to find the third, we always use the Pythagorean theorem. Now, there's one thing we've got to be careful with here is that slanted side, our hypotenuse, is always C. So I'm going to plug in my 8 here. I'm going to leave B as my variable, and then my other my other number 6 is going to be over here. So now I get to go ahead and simplify. 6 squared I know is 36. 8 squared is 64. I want to get B by itself, so I'm going to subtract 36 from both sides. And here I'm going to get, I think, 48. 64 minus 38. Oh, I was, wait. 64 minus 36. It's 28, not 38. B squared equals 28. And then our last step is going to get B all by itself. So I take the square root of both sides. That cancels out my exponent. B equals the square root of 28. And if I type that into my calculator, I'm going to get a nasty decimal, which I don't want. So we got to remember our process of simplifying our radical here. Remember, we want to break apart our radical into two numbers. One of them is a perfect square. So my number can't be greater than 28. So my first perfect square I could try is 25. That's not going to divide 28. So then I would try 16, but that one doesn't work. 9 doesn't work. But then I arrive at 4 times 7. Gives me 28. I'm going to give both of my terms their own little radical. And the square root of 4 is 2. The square root of 7 doesn't simplify. My answer here is 2 radical 7. And I'm going to type that into my box. 2 square root 7. All right, moving right along to our next one. There's a button that I can press to clear my screen. My next one is the same type of problem. Notice I have a right triangle and I have a missing side length. Notice again that this is the hypotenuse. So when I go to plug in a squared plus b squared equals c squared, the hypotenuse is always c. So I'm just going to call that x squared. A and b can be any other number. So I'm going to put 7 squared plus 24 squared. And I'm going to type that whole thing into my calculator. Maybe I'll put that on Desmos. 7 squared, 24 squared. And when I go to add them together, it's 49 plus 576. So it gives me 625. So if I go back over here, 625 equals x squared. And I'm going to go ahead and take the square root of both of those. Now, 625 is a pretty big number, and I'm not sure if it is a perfect square or not. So the first thing I'm going to do is just take the square root of it, 625. And I notice here that my answer is a whole number. So I don't have to go through that process of simplifying my radical when my answer here is just 25. The square root of 625 is 25. All right, moving on to our next one. Classify the following statement as true or false. This is the converse of the Pythagorean theorem. Now, this is a little tricky because we normally wrote our problems out this way. So when a plus b squared was bigger than c squared, we said that that was acute. And when a squared plus b squared was less than c squared, we said it was obtuse. So we got to figure out which category this one's in. The c squared is the bigger number. That would be this part right over here. So is the following triangle acute? No, it's obtuse. obtuse. So I'm going to go ahead and say false. I think we're going to use that same exact formula for our next one. It says the lengths of the sides of a triangle are 3, 4, and 5, classified as acute, right, or obtuse. So this is where we take the two small ones, we square them and we add them together and we compare it to our last one squared. 3 squared is 9, 4 squared is 16, 5 squared is 25, 25 to 25. This is where we put our inequality symbol, but this time hopefully we see that we're equal to each other. Whenever we get the two sides equal to each other, then we have a right triangle because it satisfies the Pythagorean theorem. Number 5 is our 30, 60, 90 triangle, and we're given the hypotenuse. So we had these formulas in our notes, but the first thing that I want to do is find my short side. And that's the one that's directly across from my 30-degree angle. I know my short side is my hypotenuse divided by 2. I know my hypotenuse is 18, so if I divide that by 2, I just get 9. I can put 9 in my first box for x. Y is my long leg. And I know that my long leg is my short leg times radical 3. But now that I know that my short leg is 9, it's just 9 radical 3. And remember, we could type that into our calculator, but we're going to get a crazy decimal. So I'm going to leave this in radical form, 9 radical 3. My next question is a 45, 45, 90 triangle. Again, notice that I'm given the hypotenuse here, and I want to find my legs. Now, the first thing we want to remember is that our legs are congruent to each other. So y and z are going to be the same value, and the leg is equal to the hypotenuse divided by radical 2. Well, I know my hypotenuse is 16 radical 2, and if I divide that by radical 2, these two radical 2's cancel each other out. So I'm just left with 16. So both of my legs here have a value of 16. Oops. Moving right along, we are halfway through. This one is a 45, 45, 90 triangle, but now we're given the leg value. This is my leg. I know that this other side is my leg, so I know that this one equals 11 as well. But now we're trying to find the hypotenuse. This is the formula that says the hypotenuse is equal to the leg times radical 2 this time. Instead of dividing by radical 2, we're just going to multiply. I know my leg has a value of 11. So my correct answer here is 11 radical 2. And I think our last problems are trigonometry, which are fun. So number 8 asks us for the ratio of tangent of A. The first thing I notice is A. I'm going to circle it. And then I need to know that tangent is opposite over adjacent. My opposite side is the one that's directly across from A, which is 12. My adjacent side is next to A, which is 35. If we wanted to, we could label that 37 as my hypotenuse. Opposite over adjacent would be 12 over 35. 12 over 35. My next one, I've got the same picture, but I have different numbers this time. And now I'm using angle A again, but now I'm using sine. So I got to remember that sine is opposite over hypotenuse. Opposite is directly across from. Hypotenuse is that slanted side. My opposite is 8. My hypotenuse is 17. And I'm just going to type my fraction in my answer box. 8 over 17. Number 10, now we're going to use our trig functions, which is why I've got my Desmos calculator pulled up. I want to find the value of x. So instead of being given the angle that we want to look at, like letter-wise, like our last problems, we're actually given an angle measure, like a degree. So from this angle, we get to label our side lengths. Directly across from is our opposite, and our slanted side is our hypotenuse. So I'm asking myself, which trig function uses hypotenuse and opposite? And I should know that that is sine. So the way we set this up is we say the sine of our angle is equal to the opposite over the hypotenuse. And then we get to plug in our numbers. Sine stays the same. My angle was 29 degrees. Opposite was x. Hypotenuse was 25. So I want to get x all by itself, but it's currently being divided by 25. The opposite of dividing by 25 is multiplying by 25. Those 25s are going to cancel out. And this is what I'm going to type into my calculator. And it says round to the nearest 10th. So in my calculator, I'm going to do 25 times sine 29. Oops. And that says 12.1. 12.1. My next problem, I think, is very similar. We're given the angle here. So I'm going to label my sides. This is my opposite. And this is my adjacent. So which trig function uses opposite and adjacent? Well, it's tangent. Tan of our angle equals opposite over adjacent. So I plug in my three values. Tan of 40 equals x over 10. I want to get rid of the 10 in my denominator, so I'm going to multiply both sides by 10. My 10s cancel each other out, and this is what I'm going to type into my calculator. 10 times tan of 40. That is 8.39. This 9 is going to bump my 3 up to a 4. So it's going to type in 8.4. All right, and we've got 2 questions left. The next one says find the value of x. Notice that x is our angle measure this time. So I want to find the angle. I'm going to label my side lengths again. This is my opposite. This is my hypotenuse. So if we were setting up these problems like we were setting up the last ones, we would say we got to use sine of our angle is opposite over hypotenuse. Well, my angle this time is x, and the opposite is 10, and the hypotenuse is 27. Notice how our variable is stuck inside these parentheses. The way we're going to get out of there is by doing our inverse trig functions. We're going to say x equals sine inverse of 10 over 27. So if we want to find an angle measure, you're using the inverse trig functions that has that little -1 next to it. So I'm going to do sine inverse of 10 over 27. And I get 21.7. And I think I'm supposed to round that up to the nearest whole number. So I might do 22. Awesome. And our last problem here. Use the inverse trigonometric keys on your calculator to find the measure of angle A. We've got here our adjacent, here our hypotenuse. Which function relates the hypotenuse and the adjacent together? It is cosine. Angle A equals cosine inverse of adjacent over hypotenuse. Cosine inverse of 36 over 54. And then that's the last one I'm going to type in my calculator. Cosine inverse 36 over 54. Ooh. I don't know how to undo that. It's a 48.1. So I'm going to leave that as 48. And that is my last problem. So we can make sure we submit our work. We can see our score here. If you want extra problems to study from, you can view the question again and you can do similar question. And then you can practice these as many times as you want. And hopefully this is helpful. I will see you all on Wednesday when we take our Topic 8 test. Bye.